Hello everyone, welcome to my channel. In this session, I'm going to share how to change database compatibility by keeping stable performance. While maintaining SQL Server, we have to regularly upgrade it to newer versions, right? From 2016 to 2017 and 2019, right? So as DBA, I think you are much aware of this. During this process, we also change database compatibility. What is database compatibility? Database compatibility determines how certain database behaves work with newer versions. For example, it affects the syntax of some T-SQL statements, the query optimizer's behavior, and the available features. For example, the following graph details what major features become available when you change database compatibility in different SQL Server versions. This is good, right? Higher compatibility, more features, and more improvements, of course. However, there is one issue. When you change to higher database compatibility, some of your queries' performance might get worse because not all the queries perform better in higher compatibility. When you change compatibility, a new query plan is generated for your existing database queries, and Microsoft does not guarantee that these new plans with new compatibility is the best or better than the previous old plan with old compatibility. Okay? So what should we do? Imagine you have a very important production server and you should upgrade it to new compatibility, but you are afraid of upgrading it because you might face performance issue and as a result high business costs, right? So, if so, should we keep our database with old compatibility since there is a risk of performance degradation? This is not option, right? When we upgrade SQL Server to newer versions, we should also upgrade database compatibility. In this session, I will show you how to effectively upgrade database compatibility and keep stability of your queries. Let's get started. Okay, what steps we shall follow? First, we upgrade SQL Server from old version, imagine 2012 to 2019, okay? This is SQL Server instance upgrade, and this upgrade does not automatically change database compatibility. Database compatibility is kept with old compatibility by default. In the second step, we enable query store for our databases. Then we wait for a couple of days so that query store can capture queries and plans and establishes a performance baseline with previous database compatibility. We should stay at this level long enough to capture all plans and get a stable baseline. This can be the duration of usual business cycle for production workload. Number 4. We change database compatibility to latest compatibility and let queries generate new plans with new compatibility. And finally, we use query store and check whether our queries improved with new compatibility or not. If not, we can enforce old query plan. In this way, we keep stable query performance. If there is a failure in enforcing old query plan, we can revert back to old compatibility. Yes, you can revert back at any time. Then after reverting back, of course, you can contact Microsoft support so that we can troubleshoot and help you. We are always happy to help you. Let me show you these steps with a real example. I think you are waiting, right? I have this SQL Server where I recently upgraded from 2012. I don't show how upgrade because it is very much simple. I just run SQL Server 2019 setup binaries. That's all, okay? This is just SQL Server instance upgrade. I have this database. Let me check compatibility of my database. I can see that it is still standing 110. As I told you, right? SQL Server instance upgrade does not change your database compatibility. It stays the same by default. So next step, I will enable query store. First, let's check whether query store is enabled for my database. As you can see, it is not enabled. We can also check by using SSMS UI. You can see it is off. Then we enable query store. I usually use this T-SQL. You can change the parameters if you want by using MS Documents. All parameters are documented by Microsoft. You can find online. Important point is I'm allocating 1 GB for my query store and capturing all queries and flushing data to disk every 900 seconds. Let's also confirm the same with SSMS UI. One point. If you predict many queries are run in your production server and 1 GB is not enough for your query store, you can just adjust 1 GB by increasing it to a higher number. Now, let me check existing plans and queries in Query Store. As you can see, our Query Store is empty now because we have just created Query Store, right? And it will be populated from this point. In real case, we should wait for a couple of days so that our queries are run against this database and statistics of our queries are saved, okay? For our demonstration, let me run this file now. Here I have created several queries and I run this file with ostress tool. Here I am making 10 parallel connections and running the file 10 times in each connection by using RML utilities tool. So my query started. Let me check how my query store is being populated. I run this query and check existing query plans in Query Store. As you can see, after I started executions, 2 query plans have been generated already. Then I use this second query to see runtime stats. As you can see, my queries are being run with compatibility level 110 because my database adds this compatibility now, right? We can see query plan and plan ID here. How many times I have executed this query is also here. Then we can see the average duration of our queries. On average, our query is reaching maximum this number of duration. Okay, we use this average duration as performance metric, as baseline. Let's run our queries again and see how query is being populated as long as we keep running our queries. Now you can see more and more execution plans are being generated for each of our queries, and execution stats for each queries are being generated. So in this way, I waited for about 3 minutes and let the query store to be populated. Then I stop the query execution. Now I have the baseline data. We use this data to compare in later steps when we upgrade compatibility. Next, we upgrade compatibility by running this alter command. I think you are much aware of this. As you can see, my database compatibility now 150, which is SQL Server 2019 compatibility, right? From this point, new execution plans will be generated for each of our queries for this database with new compatibility. Currently, no query is being run, and we have query plans with 110 only. Let's now start our query execution for our database with new compatibility. As you can see, new query plans with 150 is started to be generated, and our runtime stats also started to record with new compatibility and new query plan. Let's wait for a while until more data is inserted and more query plans are being generated for new compatibility. Let's now stop the execution. Okay, now we have baseline data and new data. We can compare easily, right? As you can see, our first query improved slightly with new compatibility, but the second query got worse. This is what I'm talking about. Okay, this query got better. Okay, this query worse, and this query got better twice. Great. Okay, now we have been able to compare our queries and saw the impact. The performance difference here is not so big in my case, right? But in your case, the difference might be huge. Okay, your production might stop even. So what you should do in this case, if your query performance got worse, we have statistics, we have runtime, we have query plan for each case. Simply you enforce old query plan and mitigate the performance issue. Please understand that I am saying mitigate, not resolve issue. I'll explain later why. We use these queries to enforce old query plan. First, I identify query ID and plan ID based on this query. Then I run the storage procedure to enforce old better query plan. That's all. Now this query uses old better query plan and you are able to keep stable performance, right? You can check this query to check whether the query plan is enforced or not. As you can see, it has been successfully enforced. Now your queries again became stable and normal. So, before finishing this session, I want to point out a few things. Why I am telling it is mitigation, not resolution. This mitigation technique which I showed now is not a long-term solution. This is a short-term solution. I cannot say temporary because it is not so much temporary. It is short-term solution. In the future, your database changes and your statistics changes. If so, the query plan also should be changed, right? We cannot keep enforcing the query plan forever. Therefore, use this technique as mitigation technique. And if you face performance issue with high compatibility, troubleshoot query plan. Find out why your query is taking time with new compatibility. Okay? You might change, adjust your queries if necessary for new compatibility. If you need help, of course, you can contact MS support. Okay, so to summarize, the technique which I showed, it is just a mitigation technique for short period of time and keep your production keep running, right? In the background, you can just troubleshoot your queries, why it is not working with new compatibility in your test servers, okay? And provide more long-term solution. So that's all. Please do not forget to like this video if you found this information useful and follow for more interesting sessions about SQL Server. Thank you for your time.